There's been a lot of recent discussion about agricultural carbon markets in the U.S. There are both challenges and benefits for farmers and companies involved in agricultural carbon markets. I want to discuss a few of the challenges related to agricultural carbon markets, but this does not necessarily cover all challenges. One challenge with agricultural carbon markets is actually measuring if the carbon is stored in the soil. Within this challenge, you have the additional challenge of measurement costs. There are different tools that can be used to measure soil carbon. Each tool has pros and cons, and every tool has some measurement uncertainty, but that varies from tool to tool. The main measurement tools are remote sensing, indicators, and soil sampling. Computer models can tie these tools together. Remote sensing involves using satellites to look at agricultural practices such as tillage. Remote sensing is both scalable and inexpensive, but may not be as accurate as on-the-ground measurements. You can also use soil sampling, but this is more expensive and not as easy to scale. Indicators are things that indicate the levels of greenhouse gases that could be emitted from the field, such as the amount of fertilizer added to the field. Figuring the most cost-effective and accurate way to measure soil carbon is a challenge. Another challenge in agricultural carbon markets is permanence. Permanence means once the carbon is stored in the soil, that it will stay there. The problem is soil carbon storage can be reversed if the practice is stopped, or in the case of a severe weather event. For example, if the farmer switches to no-till, then this tends to increase the carbon in the surface layer of the soil. If the farmer decides to leave their contract and till the land, or if the contract ends and the farmer tills, this can release most of the stored carbon. Another challenge in agricultural carbon markets is scaling and regional differences. Scaling agricultural carbon markets to the entire country is difficult. Carbon storage can depend on soil types and climatic conditions, so not all carbon sequestration practices are suitable for all regions of the U.S. There are a lot of different crops being grown, differences in farm size, and different practices being done, so it's a challenge to standardize to all systems. Models are not at the point to standardize across all systems yet. With further data collection and new sampling and measurement technologies, scaling could become easier. A carbon credit has to satisfy the idea of additionality, which means the adoption of the greenhouse gas reducing farming practice would not have occurred without the carbon market. Farmers who have adopted these practices in the past would not satisfy this requirement of additionality. This is one of the reasons why the practice must be recently adopted for the farmer to be eligible to receive carbon credits. The requirement that the practice must be newly adopted could lead to some challenges because this could create an incentive for someone who adopted this practice in the past to stop the practice for a year or two and then adopt the practice again to be able to receive carbon credits. The final issue to mention is carbon leakage. Carbon leakage is where a company decides to move their production from a country with stricter emissions policies to a country where the policies are less strict, which causes an increase in greenhouse gas emissions in that country. This makes it appear as if the emissions have been reduced, but in reality the emissions have been moved somewhere else. This will be a challenge to watch as the U.S. and international carbon markets evolve. These are a few of the challenges in the agricultural carbon market is facing.